Hello and welcome to this lesson on fuel cells. In today's lesson, we will look to understand the basic principles of fuel cells. So far, you've become familiar with how chemical cells convert chemical energy into electrical energy, and how rechargeable batteries can be recharged by reversing the chemical reaction. Building on this foundation, today's lesson will enhance our understanding by introducing fuel cells, which represent a different approach to generating electrical energy. By comparing fuel cells to the traditional chemical cells we have already studied, we'll explore new mechanisms by which chemical energy can be efficiently converted into electrical energy. This will advance our chemical understanding by expanding the variety of methods we can use to produce and harness energy in practical applications. Let's get started. Fuel cells are devices that convert the chemical energy of a fuel directly into electrical energy through an electrochemical reaction. Unlike traditional chemical cells, which store chemicals internally, fuel cells require continuously supplied reactants, such as fuel and oxidizer, from external sources. Similar to a battery, a fuel cell consists of two electrodes, an anode and a cathode, separated by an electrolyte. In a typical fuel cell, the fuel, such as hydrogen, is fed into the anode and gets oxidized, while an oxidizing agent, such as oxygen from the air, is supplied to the cathode. To understand this better, let us examine a specific type: hydrogen fuel cells. Hydrogen fuel cells are one of the most common types of fuel cells, and they use hydrogen as the fuel and oxygen as the oxidizing agent. Hydrogen gas is fed into the anode. There, the hydrogen molecules are oxidized, releasing electrons and forming hydrogen ions. Here is the equation that shows this. These released electrons flow from the anode through the A wire of an external circuit to the cathode. This movement of electrons through the circuit generates an electrical current, which can be harnessed to power devices. The hydrogen ions also move away from the anode to the cathode, but they move directly through the electrolyte. At the cathode, oxygen from the air interacts with the electrons, which have reached it through the external circuit, and hydrogen ions, which have reached it through the electrolyte. This reaction produces water as a byproduct and is shown by this equation. When we combine the reactions from the anode and the cathode, we get this overall reaction for the hydrogen fuel cell. One major advantage of fuel cells is their ability to operate continuously. Unlike traditional chemical cells, which contain a finite amount of reactants, fuel cells receive a constant supply of fuel, like hydrogen, and oxidizer, like oxygen, from external sources. For a fuel cell to function efficiently, it must have a balanced and steady supply of both hydrogen and oxygen. If there's too little of either, the reactions are incomplete, reducing the cell's power output. Conversely, too much hydrogen or oxygen can also cause problems, such as flooding of the electrodes or, in extreme cases, dangerous situations like uncontrolled combustion. Fuel cells also need to maintain specific operating conditions, like optimal temperature and pressure, for the reactions to occur efficiently. Control systems and feedback mechanisms are used to monitor and adjust these conditions, ensuring the fuel and oxygen are balanced and the environment remains ideal for energy production. Hydrogen fuel cells have a wide range of applications. For example, they are used in fuel cell vehicles such as cars, buses, and trains, providing a clean alternative to traditional gasoline and diesel engines. These vehicles emit only water vapor, significantly reducing air pollution and greenhouse gas emissions. Their versatility and clean energy production make hydrogen fuel cells a promising technology for a sustainable future. In today's lesson, we delved into the basic principles of fuel cells and how they differ from traditional chemical cells. We learned that fuel cells convert the chemical energy of a fuel directly into electrical energy through an electrochemical reaction, continuously supplied with fuel and oxidizer from external sources. We explored the structure and functioning of fuel cells, noting that fuel is fed into the anode where it undergoes oxidation, releasing electrons and forming ions. These electrons travel through an external circuit to the cathode, generating an electrical current. At the cathode, the oxidizer reacts with the electrons and ions to produce water as a byproduct. This continuous operation is a key advantage of fuel cells, allowing for sustained power generation. By understanding hydrogen fuel cells, we gain insight into a sustainable and efficient energy source that has the potential to significantly reduce our reliance on fossil fuels and decrease environmental pollution.